on air, it says on air.
I'm live.
Welcome to the Boston PM meeting for this month. This is March 2015 for anybody watching it via time travel. Our speaker tonight is Mike Stemle, who will be titling us about message queuing and stuff. Since we've got a remote speaker, I'm going to skip the introductions around the room. We may do those after we stop taping. With that, go ahead, Mike.
Hi. So let me go ahead and start the screen share. There we go. So my talk tonight is on AMQP RabbitMQ. This is white fluffy tales of RabbitMQ in production. Please forgive my slides. I hate making slides. So the most important thing that I could put on this is that this presentation itself is mine. I did it all by myself. If there are any errors in it, they are also mine. The work, however, that was done, this presentation describes the body of work done by the engineering team here at ThinkGeek. We've got a really good team here. They worked particularly hard to get this project underway and completed, and it's been highly successful. So if nothing else gets out of my mouth tonight, the appreciation I have for the team that I work with over here is probably the most important. Maybe not for you, but for me. So my involvement, I work at ThinkGeek. We implemented a RabbitMQ solution where we integrated our existing Perl application with AMQP RabbitMQ. That's the means by which we communicate with the RabbitMQ server. Let's see. We encountered some bugs in the resolution. I was the team member who fixed the bugs. And as no good deed goes unpunished, I am now a maintainer or co-maintainer of AMQP RabbitMQ. It's been a fun project to contribute to. I am going to confess that I am not a subject matter expert on RabbitMQ. I know an awful lot about it, and I know how to make it work. I know our implementation of it. I am constantly learning new things about RabbitMQ. It goes really deep. It's a big system, and it has a lot of flexibility, and it's crazy fast. It's highly configurable. So yeah, that's repeating myself, but I am a subject matter on AMQP RabbitMQ itself, the Perl module. Yes, it is possible to be a subject matter on one without being a subject matter on the other, because all I am a subject matter expert on is the ties between AMQP RabbitMQ and the lib RabbitMQ C library. Most of the implementations that I'm aware of that talk to that go from the more dynamic languages to RabbitMQ, I believe that includes PHP, Python, and Ruby. I could be mistaken. That's my understanding, though. Go through this same library. So the system that we started with at ThinkGeek was an e-commerce platform. We did online transaction processing. There were reportings, financials came out of it, inventory management, or inventory management even, total global domination, which is what we do here. And we had minimal integration with third parties. All those integrations were rather deep. They were rigidly tied directly to hooks with those partners. They were tied to the data formats of those partners as well. RabbitMQ itself is a robust message queue server. It's written in Erlang, and from what I understand, there are two primary protocols that are used for it. AMQP, I believe, is the most common. I believe there's also support for Stomp. It has robust support, even commercial support options, and there's a pretty wide community behind it. It's also got a really nifty web interface for administration, which has actually served us really well in development and troubleshooting. It's also great for monitoring. So RabbitMQ most often, I believe, works on a publisher-subscriber model. A publisher is a client that sends messages to the server. A subscriber is a client waiting for messages from the server. There are two common ways to get them. There's what's called a get, where it basically goes out and pulls the server, and then there is a consume with a receive, and that's actually a blocking operation where you open a connection, you tell the server you're ready to listen, and then you sit there and you wait on the wire for data to come back. We've used both of those to great effect here at ThinkGeek. Some work better than others for different use cases. Then there's an exchange. The exchange is the endpoint that the publisher uses to send messages. Okay, so the exchange is the endpoint that the publisher sends messages to. Then there is the queue, which is a buffer into which messages are routed by the exchange. The routing key is a string that you publish alongside your message to help the exchange route it appropriately. There are also headers associated with each message that you publish that you can send in that you don't necessarily have to. And there are different types of exchanges, some of which care about your headers and some of which don't. And there is a binding. A binding is a relationship between an exchange and a queue. It is a many-to-many. Each queue can have multiple different bindings to multiple different exchanges with different parameters. An exchange can have bindings to multiple queues with different parameters. It really does depend on what you want to do with it. A queue without any bindings can actually also receive a message because there are default built-in queue or exchanges which will route to a queue if you need it to. Or there's one called AMQ.star, and if you actually publish to AMQ.star and you give a routing key of a specific queue name, it'll bypass the exchange entirely and go straight to the queue. There's all sorts of little tricks like that in routing that you can use to get from one point to another. So you guys might have seen this on your all's meeting invite on Google+. So this is courtesy of RabbitMQ.com. This is in their documentation. It's a very simple and elegant way of illustrating how this works. A publisher is just a program, any program at all that publishes a message. That message goes straight into the exchange. The exchange then has a variety of routes that it could take. Some of them might involve routing keys. Some might involve headers. Some may just be bindings between things. Then, of course, there's always the possibility that you have a custom-coded exchange, which is totally supported in RabbitMQ, though I haven't delved into that too much. Then there is the queue, which is the buffer. The buffer holds onto the messages. It's it's very much a queue in the sense of the word queue. So it's FIFO. The messages go in a specific order, and they come out in the exact same order in which they were received. Kind of the opposite of what the power company keeps on telling you. So then there is a program called the consumer, which one way or another, either via get or via consume receive combo, takes a message off of the queue and does what it wants with it. Going back here real quick, once the consumer receives a message, there's essentially three options that the program has with regard to the consumer. and no matter what it does, it's always making one of three choices. It can acknowledge a message or ACK it, which will actually result in the message being removed from the queue. It can reject it, which will then it will discard it if there's no dead letter, which we'll talk about later, but if there's a dead letter, it'll send it along to dead letter. Or it can choose to do neither. And if you choose to do neither, the message essentially goes back into the queue, attempting to maintain the same order in which it came out. So onto exchange types real quick. I'm trying to watch chat just to make sure that if there's any questions along the way, I see them. So with exchange types, there is a fan-out exchange type. This is an exchange which routes to all of the queues which are bound to it, regardless of the routing key, which actually does mean that the routing key is indeed ignored. So an excellent example of a fan-out exchange would be if you have a place that say you have people publishing orders to your exchange. They publish an order. You want to send that order onto a warehouse, and then you also want to send that order into a place where we can archive it so that later on we have a record of that order locally, just in case something goes wrong with it. A fan-out will transparently send it to both locations, or to two different queues, and then you can have different programs pulling from different queues for that. You can have a direct exchange. A direct exchange routes to queues based on pattern matching against the routing keys. It has its own flavor of regular expressions, which once you learn how to use it, it's actually pretty clever. It's a great way of handling some basic pattern matching when it comes to queues. There's a topic, which is very similar to a direct exchange, except that the routing key has a specific pattern that it must follow. I believe it uses dot notation of some type. So you can say, you can have a nested tree, so you could have order.web, and then messages that you want to, orders that only come from the web could go to queues bound at orders.web, and then if you have orders.brick and mortar, you could have a different queue that's orders.brick and mortar, and then you could have messages that go to both of them saying orders.star, and it would end up in both brick and mortar and web. That was perhaps a bad example, since you probably wouldn't want orders to come in that way. So then you have a topic, or sorry, headers. Headers I haven't played with yet. I put it in here because it's in the list, but I haven't found a use for it just yet. This is messages that are routed based on specific patterns in their headers. This is something you'd configure during binding time. So routing is done by an exchange. Sorry, the question is, what is routing? Routing is something that's done by the exchange. When you send a message into an exchange, it's responsible for routing. Routing is based on the parameters that you provided when you were publishing to the exchange, which is a combination of routing key and headers. A message makes its way from an exchange to a queue based on those parameters. No matter how complicated and flexible your routing is, it can always be more complicated and flexible. One thing I found for sure, no matter how complicated and flexible I thought it was, it can always be more complicated and flexible. Oh wow, font size. So why is this desirable? Why would you want to do this? This allows for applications to be loosely coupled. Not all integration pieces then have to be coded directly to one another. So if your warehouse has a specific format and your other warehouse has a different format, Well, you don't have to now you don't have to have two different programs that package the whole message and send it over. Now you can have the thing that sends to the warehouse uses a standardized message format, and then the program that's responsible for sending it only to that warehouse parse that format, package it for that specific warehouse, and send it off. So you can have much smaller pieces of code doing much smaller tasks, resulting in a more reliable system overall. Different pieces of integration can use different formats, so you can add pieces to translate between those different formats more easily this way. Interactions can also be more asynchronous, which allows for one system to keep processing if the other one slows down or goes offline. And we've seen this before. Some programs are faster than others because they have less work to do. If you have a backup, it's nice to be able to let the one program that's collecting stuff, collecting orders from customers or processing orders to determine where it goes now. It's nice to have those being able to crank along when the program that's actually sending, packaging the order up and sending it out to a warehouse is having a hard time keeping up during a heavy peak load. Third parties can just send messages in or receive messages out without having to code to an API. Web services are wonderful, but sometimes having some manner of RPC is just not terribly useful or necessary. Just as databases have made it easier to save data in a more structured format without sorry, the maintenance folks just came in and flipping lights on and off. Just as databases have been useful in reducing the amount of data access code that we use, opening files, writing structured data, indexing, things like that. This simplifies communication between two different programs for a very specific purpose. So this changes the focus of your programs from what's my API to what's my data. You now have two integration pieces. One saying, I got this data, I know to change the program completely without any other integration pieces noticing that something changed. As long as the message formats are the same, your programs don't need to be your programs don't need to be any the wiser.
Can we back up to what's my data? We had a network.
Sure, not a problem. Are we good now?
Yep.
All right. So yeah, the change of focus is from what's my API, where you would have to previously have your one program making a series of API calls, to now your program can focus on getting its data ready in in whatever format you need it to, and putting it on the wire. And then when it ends up in the queue, the other program takes care of all the work for it. So you can now have smaller programs that know what to do with the data, and everything's all in the standardized format. So all the programs know how to talk to one another. This is great because, where we used to have to do SOAP calls to send data over with a method to call a method, and then you get your response back and all that, you drop the message and you forget it. Now you can also, with this, you can also change the code completely without various integration pieces. Oh, you're off screen share? Alright.
Yeah.
That's alright. If I'd known you guys were going to watch me all night, I would have tried to be more attractive. Would have tried. Probably not succeeded, but I would have tried. So, yeah, allowing your code to change completely without the integration pieces noticing is great for releases, upgrades, adding entirely new pieces in, removing old legacy pieces that are now gone. And then, of course, it allows you to iterate over message formats, because now you can just, oh, you need a field, add a field to the message definition and make sure all your programs can downgrade well. So some good uses of RabbitMQ as a means of communicating messages between two different programs over a network. This seems like a really simple concept, but it's a lot more, it's not as intuitive to some folks as I would have thought it would have been. It is also great as a means of integrating different applications without trying to tie the applications, without tying the applications tightly to one another. So again, no APIs to code against, no library, no integration-specific libraries to install, no learning complex data models. Just here's a message format, drop your message format in, go. Some bad uses. I've seen some programs that like to use a queue as a way of buffering data for the same program. That's not always going to work well. Rabbit is not going to be a good way of storing data. It's not going to be a good way of persisting data. It will store data for disaster recovery purposes if you configure it to do so. But once a message is pulled out of a queue, it's gone. Then clustering over a wide area network. We'll cover network partitions later, but while Rabbit supports a rather robust, it supports clustering, and it has a really integrating, sorry, losing words here. It has a really clever way of integrating clusters. Some clusters can have some stuff, other clusters can have other stuff, and of course all the clusters can share a certain set of stuff. But clusters should only happen on the exact same network. We've had latency problems which have caused network partitions, and that usually results in a day or two at least of headaches and some manual fixing. So what did we develop? Well, we're ThinkGeek, so we like to do clever play on words. So we developed Quidditch. Our existing application was called Sforb, which is, as you may know, a combination of a sphere and an orb. And what we wanted was a more lightweight system that kind of traveled more rapidly and went wherever you wanted. So that was a snitch. A snitch is kind of like a sphere and an orb, but it's tiny and it has wings. So with this, we have Quidditch, we have snitches, we have bludgers, and we also now have quaffles. Our terms are Sforb is our existing e-commerce platform. It's all in Perl. Then you have a snitch, which is a daemon reading from one source, which could either be a queue or a daemon reading from one source. So that would be any data source, be it a program, data that was just in memory, a database, whatever, and publishing to an exchange. Another example of a snitch would be a daemon consuming from one queue and then writing data to another program or data store. So that would be a daemon process specifically that's either sitting and taking data into or out from Rabbit. Then you have a bludger, which is a program consuming data from one queue and publishing it to an exchange, having manipulated the data along the way. So you get a message from you get a message from somebody in XML, and you wanted it in JSON for use in another program. So that's what we call a bludger. It's a program that will take your XML message off the wire, and it will convert it to JSON, and then it will put it onto the exchange, and then it will be routed on the program for its own. It'll be routed back to the program to move along. A quaffle is a program that's like a snitch, with the distinction that it is a cron job. So it's a program that runs and then exits. A snitch is never intended to exit. And then we have integration points, which are third-party systems that we integrate with. So this is an example of what I just described. right here. I'm hoping you guys can see my mouse cursor. I'm hoping you can see my mouse cursor.
Yep, we can see the mouse cursor.
Excellent.
So the integration point would be a muggle.
Oh, okay. Hold up 1 second. I'm writing that down. Where's my pen? Writing that down. All right. I'll go ahead. That was Bill, right?
Yep.
All right. I'll credit you.
You may steal that.
Oh, we're gonna steal that. So Sforb. This is our existing Perl application. This does OLTP, and this is just data coming off of it. It's coming in an XML. It goes straight into Rabbit. Well, this integration piece over here, it wants JSON. So so the integration piece, Sforb publishes data into RabbitMQ. This goes into an exchange. The bludger over here picks the data up off of the queue, right? You always publish to an exchange and read from a queue. This is data pre-processing. The bludger then processes the data, and the data post-processing goes back into an exchange in RabbitMQ. Later on, from the queue that the bludger's post-processing data went into, gets picked up by the snitch. The snitch then takes that data and sends it off to an integration point. A lot of times programs will do this serially, but one of the things we found is Sforb is capable of collecting data really fast, right? We can take orders off the web really fast. This bludger right here can run even faster because it only has one job. Its one job is to take data from in XML format and convert it to JSON format. In the event that we wanted to have, say, a second instance of Sforb, we could have two instances of Sforb here writing to Rabbit, and then we could have the bludger processing at its faster rate of speed, because Sforb is slower than the bludger, but the integration is the slowest piece of all. So we take the data from Sforb, we process it, we put it on here, then the snitch picks it up and sends it off to integration. The nice thing is RabbitMQ is wicked fast. RabbitMQ, I believe at the height of our load tests before we gave up trying to break it, I think we were able to process 25,000 messages per second. That was not with any particularly complex routing, but we were able to process, I mean, it was just a stupid amount of data we were able to get through that thing. And during all of the different integration points, we kept an eye on whether or not Rabbit itself would be able to scale with the amount of data we were sending it. And so far, any performance problems we've had have not been because of Rabbit. So what's happening here, this is just what I mentioned before. The Sforb puts the data into an exchange. The exchange routes the data to one or more queues. The exchange also routes it to an archive for logging purposes. We like to have a really nice trail of breadcrumbs to go trace back on if for some reason we find that there's a problem. We want to be able to go back and troubleshoot that. And losing data makes it very difficult to track problems. So every message that we get, we want to have an archive of it. A bludger consumes data from a queue. It then takes that data and processes it. It could convert it. It could split it up. Where you're right, you could have like one really big message that actually contains a whole bunch of small ones that you want to split up. So you can do that. Publish it, and then it publishes back to one or more exchanges. Those exchanges route data to one or more queues each, including the archive queue, because right, we had the bludger. We archived the original form of the message. Now we've processed it, and we want to collect, or we want to archive the result of what the bludger did before we move on. Then the snitch consumes the data from the queue. That snitch then passes the data onto the integration piece and acts it on the queue, which then results in that message being removed from the queue. So what about failures? all systems have failures, and Rabbit is not any different. Failures can be retried, but only so many times. Repeated failures in our system result in a message being sent to the dead letter queue for further investigation. What is a dead letter? A dead letter is a message which has been rejected for any reason. It can be automatically routed to a dead letter exchange, which is what we do. We have a policy that makes it so that all exchanges automatically have a dead letter exchange configured for them. So all queues, if you act on them, go to a dead letter exchange. Or sorry, if you reject on them, go to a dead letter exchange. If you act on them, they just come off the queue. The dead letter exchange then can route it to a queue for further investigation. Routing can always be more complex than this. Dead letter routing in particular, the header style routing or exchanges that I mentioned earlier would be a great example of how you could be more complex in your dead letter routing. You could have a dead letter exchange that, based on the headers, knows exactly what exchange that message originally came from, or what queue it originally came from, and it could publish it back to that exact same exchange or queue for processing later on. There are some problems to watch out for. Network partitions cause desynchronization for clusters. This almost always results in lost messages. Never to hilarity, but always to frustration. Problems usually don't happen one message at a time. One problem could, and almost certainly does, flood the dead letter queue. Famously, during this past holiday season, we ended up with, I think it wasn't a big thing, but it was some small thing failed, and all of a sudden we end up with 15,000 messages in the dead letter queue. That happened in an instant, because these programs are processing particularly fast, and as these messages are getting rejected, they just pile up in the dead letter queue. You should have a plan and a process in place for how to handle that if you implement that. At first, it will almost certainly be manual, but you will quickly identify ways that you can automate it. It's really something that you have to keep on top of, because it can back up pretty quickly. And if your messages are super important, like a customer's order, you don't want to lose that data. If it's data that you could just, if it's data that's going to be updated and sent again on a regular basis, letting you know the status of some system or whatnot, that data, it's probably not that important to keep an eye on if it dead letters, only that it dead lettered. So what's a network partition? I am not a networking expert, but to oversimplify, which I'm particularly good at, a network partition is when one or more parts of a network lose connectivity between each other, so that what was once one network is now more than one network. In this event, the clustered RabbitMQ servers don't know how to synchronize. And when you bring them back together, if they had if they were synchronizing between each other, you will have a high probability of data loss. Usually you need to mitigate that. We mitigate that with the archiver, and we're also looking into other ways of doing that, because it's a really tricky problem, especially as people move into things like AWS and things like that. If you're running Rabbit across those, it might seem like they're on the same network, but they might not be. Network partitions are actually a really tricky problem, and most of the implementations that I've heard of solve that problem in various different ways, or in very different ways. So the Perl module had some bugs. It was impossible to detect the connection status when we first picked it up. So the simple task of, hey, am I connected to the server? That was not a supported feature of the module when we first picked it up. This module was the best one that we found when we started picking it up, or when we started the implementation. it's gotten a lot better because of our involvement and also because of several other people getting involved as well. Several error cases didn't properly close the socket. A lot of times, if you have a problem, Rabbit will drop your connection for you. It's very kind like that. If you don't expect that, you will try writing to a bad socket. And type inferences are particularly limited. It broke all things UTF-8 when we first picked it up. Array and table header types weren't supported. You can actually have nested structures in your headers in AMQP. That is a feature that I added back in November that wasn't there, but the dead letter stuff actually stores all of its extra metadata in a table inside of the headers, and that was not something that was supported by the module at that time. So there is a lot of functionality with regards to dead letter that we weren't able to implement because of that limitation at the time. The project's challenges. This is the module project's challenges. LibRabbitMQ C is very well done, but is very sparsely documented. Almost all of what I know about this library has come from reading the code. That's not terribly unheard of, unfortunately. Coming from Perl 2C, it's difficult to know how to communicate types. How do you tell the difference between an unsigned 64-bit, an unsigned 32-bit, a signed 64-bit, and a signed 32-bit? How do you determine whether or not your string should how do you determine whether or not your string could contain wide characters? Is it an integer or is it a timestamp? Because AMQP actually has two different types for that. So you can also insert the complaint that you normally get about legacy craft here. This module has been through the ringer. It's had a lot of different hands in it. It's had a lot of people pick it up and run and then stop. That's left some of the code in a not too clean state. Then, of course, there were changes to perlguts. The Perl SV type macro, which is one of the key macros we use for inferring Perl data types in scalars coming in. In 5.10 and below, a reference is an SVT RV, and after 5.10, they actually merged those. So now everything is an SVT IV. So that's instead of it being a reference value, everything comes back from SV type with an integer value. And then you have to do further inspection on the scalar in order to determine whether or not it's like an array ref or a hash ref, or any other type of reference. This made it particularly difficult to infer what the types were without going to additional trouble. And it wasn't something that I knew when I was implementing that part, so it took a while to find. There are some things that are coming soon. Some of the things are actually done and waiting for us to package it for release. Numbers in headers and timestamps will use instances of math int64 if they're detected as a 64-bit integer. Also, we have various other bug fixes. Today, I've put in, I think, 3 issues today and 1 pull request. So we're still actively working on this module. It's not dead by any stretch. There's still some unsolved mysteries that pose a challenge to the project. One is that server responses on the wire are not synchronous. So synchronous calls are a little tricky, and this module does do things in a more synchronous fashion. When you publish a message to the server which has trouble, the server may respond right away later on, whenever it chooses to let you know what the problem was. Since you can't know when the server is going to give you that message back, it is difficult for you to detect it when it's sitting on the wire. So a lot of times those errors, we actually have an issue right now where you find out about that error on the next RPC call, which is a really big gotcha because nobody likes an error message in an irrelevant context. If for some reason an ACK fails, I don't want to find out about an ACK failing when I'm trying to open the channel again. So we're still working on it. As I said, this project is not dead. It's still moving along quite well. We're still fixing bugs. We're still adding features. We're not all the way up to AMQP 0.9.1, but we're working on it very slowly. We're still increasing our test coverage. We support Perl all the way back to 5.8.8, and so we also use Travis CI to test across those different versions. In order to use Travis CI well, you need to have decent test coverage. My favorite is that I'm not the only one working on the project. There are dozens of people reporting issues to me over. I have some people who have sent them to me through Google+, some folks who sent them through GitHub issues and email. There are about 4 people who have been submitting pull requests. There are 2 of us who've been packaging releases. Mark Ellis and I have really been going back and forth as to who's been packaging the release. It's been really interesting working with him on this project too. He's been particularly responsive, and the community that's supporting us is doing a good job. We actually get the best possible error reports. Most of the time, somebody actually gives us a program that will replicate the problem for us, which is almost unheard of in free software bug reporting. So now I would like to open it up to any questions, which I may or may not be able to answer, but I'll give it my best shot.
So I was looking at the RabbitMQ website, and under Perl, there was RabbitPut and 3 against RabbitMQ, neither of which has been updated since 2012.
I'm sorry, I'm having a difficult time hearing you.
I was looking at the RabbitMQ website.
Yes.
And if you look for Perl modules there, the 2 listed have not been updated since 2012. Have you thought about telling RabbitMQ that this module exists?
That sounds like work. No, actually, that's not actually occurred to me. I will write that down, and
I mean, the 2 listed say that the latest version they support is version 2 of RabbitMQ, so they might be happy to have a more recent listing.
yeah.
Might help people find it.
Yeah, but that means more bugs.
Yeah, well, and you know, our tribe probably knows to find you on CPAN, but just so that people know Perl isn't dead.
But more bugs that other people find mean fewer surprises for you later.
That's true. That's true. That's a good point. Yeah.
I got a question about names. Whose decision was the Harry Potter names? RabbitMQ's or yours?
I'm sorry, what'd you say?
He wants to know if the Harry Potter naming convention is ThinkGeek's or RabbitMQ's.
This is ThinkGeek specifically, and I'm actually going to go ahead and take the blame for starting this, because yeah, when we first started talking about it, like I said, our original application is called Sforb, which is a combination of a sphere and an orb. And
you wanted smaller, more agile ones, so yeah.
We wanted a small orb with wings.
Okay. I'm gonna have to get violent here. Those are very, very poor idea to pick wacky names for basically our sinks and sources of data.
It's internal to them, and they're wacky, and it doesn't matter.
Fine. I'm registering an official complaint.
Hurry peer reviews everybody. Don't take it personally.
No, it's okay. Timmy has heard your complaint and ignored it duly.
Okay. We got a question from somebody on the mailing list who couldn't be here tonight.
Yes.
His question was, are AMQP and RabbitMQ better than Gearman?
I am not familiar with Gearman.
Okay, Gearman is apparently a job queuing application framework that, so my answer was ratchet wrenches and power screwdrivers, which is better? They seem to be addressing different problems.
I agree.
Okay. Any other questions on the static slides? Did you have some code you wanted to show us, you suggested?
Yes. So...
do we need to turn off recording before you show us code?
Nope, all of this code is on GitHub.
Excellent.
The code I am showing you is... Let's see. We should probably go back to my version of this. I'm only going to show you the XS code associated with the Perl module itself. So, if you ever wanted to see, if ever you wanted to pick up a library and use it as a reference for how...
can you double the font size?
Yes, I can.
It's getting compressed.
Is that better?
One more?
One more?
Yeah, thanks.
Good.
All right, let's see if I can make sure it all gets on the screen. All right, so one of the things that I've done in the past is if I work on a project and then later on I need to use a similar technology, I will look back at a thing that I did in the past to help me remember how I did it in the past.
Yep.
A lot of times I'll also go on GitHub and I'll look for other people who've used the technology I'm trying to use, and I'll try and read their code to take a good stab at how they did that. We are doing almost everything that you can do in XS and perlguts in this code. We've got clever macros to convert from integers to hash values, or to stick integer values into hash values. We have functions that convert from a Perl hash to a table, which is a specific type in AMQP, and even for arrays. So, let's see. If you wanted to, I'll show you the type inference, because this is probably the piece of code that I took the longest to work on. This is C code, so I apologize if you're not a huge fan of C. I guess nobody's really a huge fan of C. So right here we have AMQP kind for SV. This gives us back a, this is I believe it's an enum that has different types for whatever type that we should, right? Because AMQP has a definition of how to determine what a type is, right? It has a single character value denoting what the type of a field would be. So this function takes in a Perl scalar value and this value right here that I've just added today, telling us whether or not we want to force it to be considered a UTF-8 string. And it tells us for this Perl value, it looks like it's going to be this AMQP value. So, like I said, the first thing we always do is we check the SV type, which is that macro that gives us back this enum, these enum values. So this piece of code right here represents about 2 weeks of frustration for me, because before you could have two different cases here. You could have a case for an IV and a case for an RV. So you detect that it's an IV. Now that only tells you that it is an integer or it's a reference. So you have to determine if it's a reference. Okay, well if it's a reference, what type is it? You have to then dereference the Perl value and then pass it to SV type again to see that it is a array value or a hash value. If it's any other type of reference, I don't really support you. There is no logical way to send a code ref to AMQP, and a glob type is write out. Then we can, from inside of from an integer value, even if it was just an integer value, we still don't know whether or not it's assigned or unsigned. So right here, we check to see whether or not it looks like it's signed. Sometimes we have to make assumptions when we're converting from Perl to C types. So right here, if it's a number type, which is float or double in C, oversimplifying a little bit, we are we're going ahead and telling AMQP, go ahead and treat this value like it's a 64-bit floating point precision number. Then you have a PVIV, which these are string types, right? So it could be, this is a pointer to a scalar for an integer. So it could be an IV or a UV. Number again. By pointer, sorry, I'm being imprecise. I mean reference. Then right here, this is what you get if you have a string. So this I put in today if you have a force UTF-8, or if we detect that the UTF-8 bit is set on it, we go ahead and tell AMQP that it's a UTF-8. Otherwise, we tell it it's just kind bytes, which is the default for either a C string or any other random binary data. As I'm scrolling along here, I'm sure that some of you are cringing little bits here and there for code format. This code is not consistently formatted. This code, it needs a little bit of TLC still. Unfortunately, TLC is something that we haven't had time to do with this module. This is the part where I invite anybody who's interested in looking at the module further to contact me or Mark Ellis, and we'll be happy to help introduce you to the code and get you on the hook as well. It does need a bunch of extra stuff, but yeah, fixing or reformatting code and making it fit any type of uniform code standard kind of seems secondary to making it work in production. At least for something that's so legacy when we got a hold of it. Sometimes different header types. This right here is the internal receive. A get or a receive both use this function. And inside of this, you can see that there's special types for headers. The delivery tag is a special 64-bit integer that AMQP protocol gives you. It tells you on your wire, this is the ID for your received message. I guess perhaps I'm going into the weeds, but if anybody had any questions on the code, I'd be happy to answer it for them.
So there's an awful lot going on in terms of the wrapper around this C library to this Erlang code base, where you're deep diving on the Perl data structures to convert them properly because they're rich data structures.
Mm-hmm.
Have you thought about migrating some of that conversion stuff to Perl? It might actually be easy to manage. Then you pass the information down to your API and get back into C. Because it looks like you're doing a lot of jumping around in C, where you could do it a lot more easily in Perl.
So that's a good question. One of the things that is very particular about this library is everything is done in C data structures. AMQP is a binary protocol, so the C library actually has structures that are constructed in order to get everything in the correct order to send over the wire.
I understand. Okay, well, that's very, very obvious. The question is, why can't you do more of it in Perl? You can use pack or unpack to do some of the binary stuff. You can use Perl to make better decision trees and organize your data better, and not have as much craziness in the C code.
Mostly because that would essentially be re-implementing this library in Perl. The nice thing about LibRabbitMQ C is It's a lot of syllables. The nice thing about that is it deals with all the stuff, all of the transmission of the protocol over the wire for you.
Now, you're moving the API down to the actual library. I'm talking about keeping a certain amount of C code that you're wrapping, but putting more of the logic that you're doing here higher up into Perl. That way, minimize the C code, simplify it, and you have basically an API in your own module that's between Perl from the API on the outside world, Perl and the internal stuff, and then calling your internal API to the C code, which then calls the library. It's an extra layer in there, but it would simplify the structure, I think. I'm seeing a lot of C code here that is so easy to do in Perl, but you're jumping hoops in C.
Right, and the reason that we're doing it that way is because if you look right here, this right here, just looking at this one small piece, we have a type that is this is actually going to go. This is us actually taking something from the wire, right, and converting it from a C structure to Perl. That's all we're doing here. All we're doing is taking it from this C data structure, which is using unions and things of that sort, and we are sticking it into a hash ref to return. That's all this is doing here. There's really no
wire, you're talking about an actual socket or some sort of buffer.
We're talking about a buffered socket, and that buffered socket could be plain text or it could be SSL.
Where's the code that's actually doing the SSL there? I don't see socket code.
That's because I'm using my library. When you see things like this right here is code that actually belongs to not this module, but this code right here belongs to librabbitmq, the C library. So it handles all this stuff transparently for me. It does all, like right here you can see that I have different types of frames that could come back. It could be a heartbeat frame, it could be a method frame, it could be a content frame, it could be a header frame. All the stuff that actually does the determining, hey, the server just sent me something, what is it? All of the parsing of that binary data is done in the C library for me. All I'm doing is taking the data that it put into a...
Let's drop the whole thing.
Yeah, I mean, he could build the hash in Perl, a Perl wrapper around this XS wrapper, but since he already has to be doing XS, the XS code to build the hash is going to be faster than the Perl to build the hash.
It's hard to maintain.
There's one more thing
Yes,
that I think you're forgetting.
Yes, but this is networking middleware.
Yeah.
A little hard to maintain is worth it for a lot of speed.
Also, you've got to remember there's one more layer here, which is I don't have the only moving part here. My library is not the only one that's involved. librabbitmq C is actually changing along with me. So right now, I know what this looks like, right? So you're correct. I could take this and I could use pack to take a Perl data structure and pack it into a binary format that I could just memset. But the problem is, what happens when the next version of that library comes out and that no longer is binary compatible?
You have the same problem here.
No, I don't, because I'm addressing it from the source code perspective. If he just added a field in the middle, that's fine because the C compiler is going to notice, oh, I'm not touching that new field, I'm touching all these other fields.
Then you just do the same in your Perl code. You add a new field there. Pack is a field-based system.
She's saying if the C headers change, probably all you need to do is just recompile.
That's basically, yeah.
Right.
That's true in either case.
No,
Not with pack.
Okay.
Yeah.
Okay, carry on.
Are there any other questions?
I don't think there are any other on this bit of code.
I don't know what else you guys want to see. What do you want to see in the code? There's, pretty much anything you can do in the AMQP. I guess I could show you the extent to which there is Perl code in this module. Well, non-testing Perl code.
Testing Perl code might show us how it's used.
That's a good idea. There's a decent amount of documentation here. It was mostly done, I think it's OmniIT or OmniTI that did most of it, and then Mark and I have done a little bit. We'll get to Perl code eventually. Oh, there we go. That's it. This is the extent of the Perl code because this library does not implement AMQP. This library wraps around a C library that implements AMQP. So that's one of the nice things about that's one of the nice things about this library from a contributor's perspective. It's already done for me. I mean, all of the hard work of implementing AMQP is already done in the C library. And the nice thing is I'm not the only one who's plugging into it. People who are using Python and Ruby and PHP, and I think there's one of the Node libraries that's also using this. Those people are also using the same C library. Let's see.
So it mostly probably works.
Yeah, and so that one thing I mentioned where if you try and publish and there's an error and the server sends it back asynchronously, it sits on the wire for your next RPC call. That's actually that's a challenge in the C library. I've been in communication with the people who are maintaining the C library to try and figure out how we could navigate around that, because it's something that we're not the only people who are encountering that problem. Everybody's encountering that problem when they run into this. So this is something that we're looking at trying to fix. Let's see, what's a good one? So if you wanted to just to publish a message, a bunch of this is code here to make this repeatable. Why are you not thinking in Perl? Oh well. So this right here, I'll walk you through the actual executable bits right here. Here we're just creating an exchange name, a queue name, and a routing key. We're going to connect. We grab an instance of AMQP, RabbitMQ. We connect to the server. You open a channel. AMQP is a multiplexed protocol, so you can actually, on the same wire, have multiple different transactions going on at the same time, each of them on its own channel. And then every packet that goes back and, every frame that goes back and forth says which channel it's for. So here you're opening channel number 1. You declare a queue with your queue name. Not passive. It is durable. Durable means it'll be stored to disk until it gets pulled off of the queue. Not
survive reboot.
Yeah, it'll survive reboot, or crash if necessary, depending on how well it crashes. And then auto delete. We don't want to auto delete until we have acknowledged the message. So then we're testing to make sure we didn't die while we declared it. Keep in mind, these are super duper legacy tests. Anything below, any test number below 20, I don't think we've really touched other than to add extra tests to. Then we go in here and we drain the queue. We just sit in a while loop doing a get, because get is a non-blocking call. So until this returns undef, we just keep going. Then you publish. So in the publish, you have this is the channel.
We got a question.
Sure. What's the question?
Oh, why do we drain the queue before we publish anything?
Okay, that's a great question. If I ask, we're on line 28. So you can see right here, we're actually using dev RabbitMQ, and that is because the fine folks over at RabbitMQ have given us this wonderful dev test bed to play in. You can actually see a whole bunch of people are using it. Mostly, well, actually mostly my module. Although some of this stuff is other people's modules. And this is some, yeah, this is more Perl stuff right here. I cannot guarantee that my current test that I'm running right now is the only one running a test at the moment. So in order to make the tests more repeatable, the people who originally wrote this test wrote in something to drain the queue.
So because they have that public server, you don't have to spin up your own exchange for the duration of your test.
Exactly. And the other thing is, when you have a durable queue and durable exchanges, they are. I just lost my train of thought. Oh, sorry. There we go. So durable queues and exchanges will stay. They'll stay there, right? Even when they have nothing in them, they will still exist.
And we'll eventually reuse the unique bits somewhere.
Yeah. So this right here, whenever you call queue declare, if you call queue declare, if the queue already exists and you give it the exact same parameters, it says, cool, you got your queue still. If you call queue declare and your parameters in any way changed, you get an error message back saying, no, the queue that you declared is different than the one that already exists with this name. And the same works for exchanges and bindings. Or not bindings.
Line 23 could fail if the somebody changed one of the zeros and ones on line 22 and ran this with the same unique as somebody used before. Okay.
Exactly.
Then we gotcha.
Yeah.
Don't change that.
Yeah, I think that's been one of the biggest challenges to the testing, is just making them repeatable.
Yeah.
Which I suppose is always a challenge with testing. So that's why we have this here. Is it's just an additional bit of good measure to try and live in an ever-changing environment. So here we're calling publish. This is our channel. This is our routing key. This is the body of the message. This could be any scalar, really. It could be, in that scalar you could have binary data, you could have string data, you could have number data, any kind of data. It gets put onto the wire in the exact binary order it goes in. So if you stick an image in, it'll come out as an image still. And we've actually, when we were doing our due diligence on this, I actually tested this with a 20 gig file. And it was a little bit slower. We couldn't quite get the 25,000 messages that we had gotten before. But we were able to get binary, we were trying to remember what it was. I can't remember what it was. It was a 20 gig file, and it was an executable, or not an executable, an installable or something. And it was still usable afterwards. The MD5 matched and everything, which has worked out well for us, because when you're trying to verify the message path, a lot of times MD5 is the best way of deduping a large set of messages. Drop them disk and do MD5s. So right here, this is what's considered the options. So in the options we have the exchange, and then this here is called the arguments. So you can have a content type, you have an encoding type, or content encoding, correlation ID, reply to, which can be a queue. You have the expiration. A message can have an expiration. Message ID. And some of these are actually just arbitrary headers, because, like I said, this will support arbitrary headers. Delivery mode is an important one. I can't remember what the specific modes mean. One of them means don't actually bother storing this one to disk, and the other one means go ahead and store this one to disk for sure. And then I think there's a couple more out there as well. You can also specify the timestamp. If you don't specify the timestamp, one will be provided to you. So yeah, that's a publish. Consume, there we go. What's the consume? So consume is also interesting. We connect, we open our channel, then we put it into consume mode. We have some stuff in here for timeouts and stuff, just because sometimes things don't make it along the wire as we'd hope they would. One of the challenges that we've also encountered is some of these tests depend on being run in order. So test number 3 will actually fail unless test number 2 ran before it. That's one piece that we'd like to refactor. But again, we really only have 4 contributors and 2 primary maintainers, so that's a little tricky to do with all the outstanding stuff to do. Then you put your channel in consume mode. You put your channel in consume mode, basically letting the server know that for your connection on that channel, you want to start consuming messages. Then, where are you? Right here. Right here you enter a receive. This is entering a receive with a 5-second timeout, but the receive actually is what gets you your data. And then when you get your data, you can actually see this looks exactly like the message that we sent in test number 2. All we're doing here is verifying that the message that we sent, that we got back in test number 3 is the same one we sent in number 2. I believe, yeah, this is right here. This is just trying to do a receive to verify that the timeouts work. So that's just a test. That's not necessarily a common use case. You can see in test 4 where we actually do all of that in the same place. You connect, you open a channel, you declare a queue, you bind a queue, you publish to the exchange, then you set yourself into consume mode. Notice we're using the same channel here. And then you receive on that connection. And then when you receive, you verify that it's the same thing that you published, which is just this and your routing key. Everything else is kind of boilerplate properties that the server throws on there for you, and empty header properties. Trying to think of what else is interesting.
Okay,
I think I hear a question.
Yes, the issue that you have to switch from published to,
I'm sorry, can you speak up? I'm having a hard time hearing you.
You switch the queue from publish to consume.
Yeah.
Because you're self-consuming. That's not terribly usual use case, is it?
Not really, and in my slide deck, you'll recall that I actually put as one of the poor uses of RabbitMQ a program which is using Rabbit as a buffer for itself. It's supported functionality, but I don't think it's terribly useful in and of itself. A more common case that I found is what we were calling a bludger, where it is a program that has 2 channels open, and on those 2 channels, one of those channels is receiving data and the other one is publishing data. So you would essentially have a publish on channel 2 and a consume on channel 1.
Okay. And for anyone playing along at home, hard-coded numbers 1 are not good in production code. This is a test, so they're fine.
Yes.
That's also legacy code.
It's legacy code, and tests sometimes enjoy a greater deal of leniency than production code does.
In production code, if you have the numbers, they should probably be named with variables or constants or something.
I do endorse the use of naming constants.
How do you synchronize your channels across different processes? They're just, is there, the channels have nothing to do with where the message sits in RabbitMQ, does it? Sorry, that's the exchange in the queue. Never mind, okay, I get it.
Well, and I think I heard a very good question there, though. How do you synchronize channels across processes? And the simple answer to that is you don't.
Right, because the channel is just within your process. The actual thing that the other thing has to talk to is the queue, has a queue name that it deals with.
Correct. Yeah, the channel is just to help your one process that you have open keep track of, on this one socket, which multiplexed conversation am I involved in with this specific message.
Okay, thank you.
Mm-hmm.
Does this come with example client programs that do anything interesting?
I don't really think so. I haven't actually looked much. There's manual tests. I added a manual test here. This was when I was trying to verify that I don't think this works anymore, because this was how, before we started supporting 64-bit integers, people were using PAC to as a workaround for the fact that we weren't supporting 64-bit integers. So since we fixed that, I don't think this test will actually work anymore.
Yeah.
Yeah, this right here actually verifies that when you die, you get your X death headers. X death is a special header type, or a special header name. It's a table inside of AMQP, which the library then translates into a hashref. So inside your X death headers, you can figure out the time at which it deadlettered. Here we go. The time, the exchange it came from. It'll tell you the queue it came from. The server has various different reasons for why it would. So if it had like a TTL expiration, you get expired. If the consumer rejected it, you'll get rejected. Then you have routing keys, which will essentially just be an array ref of strings containing the routing keys that were used when it was sent. As far as other tests, I think the only one we have here is, yeah, we've got a transaction memory leak. That's not a very useful one. It takes forever to run, too. Yeah. Right now we're at 74% test coverage. This has gone down with a couple of the people who have contributed, because sometimes people contribute really good patches without really good test coverage. We've been trying to discourage that strongly. Are there any other questions?
More questions?
I have a few general questions, not so much.
Sure, I will need you to speak up, though.
So the first question I had was, when you were working with RabbitMQ, was that one of many options that you had to use? Were there other message queuing systems that you looked at, or did this predate your work?
So I was actually the one who put together the initial investigation into which message queue to use. There are a whole bunch of different ones out there. The primary reason, there are really two primary reasons that we went with this one. The main two being AMQP is a widely supported protocol. There's even an OASIS standard for AMQP 1.0, which I'm not sure will ever be supported by anybody, but it's still an OASIS standard, and that counts for something. And the other thing was AMQP, among the people who support it, RabbitMQ is the most widely used one, and it is the one that seems like it has the most robust community support that we were able to find at the time. I've also got a couple of friends who work in other sectors. I've got one friend who works in Heroku who uses RabbitMQ. It's been a really interesting project to get into. I think that we made the right choice with Rabbit, though. Yeah, there are definitely a whole bunch of options, including a couple by the Apache
other
project.
options that you did look at?
Oh gosh. So there's one that was put out by Apache. Well, actually, there's two MQ, I believe, that were put out by Apache. One of which I think has been spun down as a project, and I think the other one is still. I think the other one's still undergoing bits of maintenance, but is not considered production ready. And then I think there's another one just called MQ. But that one wasn't deemed production ready. A lot of them had like, hey, this is really neat, but it's not really ready for production yet on them.
Did you look at the prior generation of commercial message queue message broker systems?
You mean like IBM and oh gosh, I hesitate. I'm having a hard time thinking of the other ones. I guess Microsoft's got one out there as well.
Yeah,
but that one's kind of right out.
There's Sonic, lovely Bedford.
I'm sorry, I'm having a hard time hearing you.
There's also Tibco and a bunch of other ones.
I think it's called Sonic.
Yeah. For cost reasons and for platform support reasons, we kind of passed those ones by. IBM's solution is it's rather commonly known that that's a more expensive solution, and we wanted to see what our options were without having to spend as much money as what IBM and other players might charge.
I wish this solution had been there when I was using MQ from IBM.
Yeah, I mean, those are perfectly good solutions. They're just, everybody's got different goals when they're going into an implementation, and ours were such that Rabbit fit our needs better. I know people who do use IBM's MQ, and they swear by it. But it kind of ruled itself out for us.
They may also swear at it at times.
They might, and I swear at Rabbit sometimes.
That seems to go with the territory.
Yep, it's a computer. You're supposed to swear at it.
Did you have another?
I had a few more. The reason I asked that was actually because my company does use IBM's MQ, and I was just curious what else is out there, but I wasn't involved in getting set up with that, and I'm not sure there was anything else available at the time. But we've been using MQ, WebSphere MQ for like 10 years.
Since before it had a WebSphere name.
Yeah. Right.
Yeah, I have no idea how long Rabbit's actually been out, but I don't think it's that old. I could totally be wrong there.
Okay. So the second question I had was, you mentioned clustering with RabbitMQ. Do you do that for redundancy or for speed, like with striping, or what is your reason for the clustering there?
Yes.
All of this.
Yes, we use it for performance, and we use it for redundancy. As I pointed out before, one RabbitMQ server was able to handle 25,000 messages per second, very small ones. I mean, like, the server was responding faster than the Perl program could pick up the data and run with it and tell us, and count it. So it was mostly for redundancy, but as programs are going along, it's nice to have a second server taking up some of the load just in case.
And does RabbitMQ handle all of that for you? Do you have to configure it in some way to do that, or?
Yeah, you have to configure RabbitMQ to do it, but clustering is part of the feature set of RabbitMQ itself.
Okay, so you just tell it, here's my servers that I want to cluster on, and it takes care of it.
Yeah, its config file is actually written in Erlang, so it's actually it's pretty easy and extensible to configure like that.
Okay. And then the last question I had was, I noticed in your test script where you were connecting to the MQ server, you had the login credentials in plain text in there. Is there some way to store those securely in your production code?
In our production code, absolutely. We absolutely store our credentials for logging into the RabbitMQ server in production securely. And I recommend that anybody else listening does the exact same. However,
what method do you use for that?
that doesn't sound like something I should probably mention.
Okay, you can't speak in generalities.
You don't have recommended best practices there. Okay.
Yeah, I think best recommended practices would be use encryption, use it everywhere, and use it often.
And don't read it from source files that go to configuration management.
Yeah, probably not. But the main reason why we have it hard-coded in the tests is simply because I mean we're going straight to the default username and password on that server. Though now that you mention it, I'm not certain whether or not these tests would actually work with different credentials. Yeah, no, they're hard-coded there. Whatever server, because you can override what server you're using on the test by using mqhost. So you would, whatever server you ran these tests against would have to be open with the default username and password.
Yep.
Which is probably fine. You should never run your tests against a production server.
Yep. Tests get a pass on things like that.
Yeah.
That's all I have.
Anybody else? Well, thank you very much, Michael.
Thank you.
If you want to stay on the line after I stop the broadcast, we're going to do our around the room hellos.
Alrighty.
We did them earlier, but